So here's one you probably haven't heard of in the air dispersion modeling world. A dry lake bed is a source of fugitive dust. So when you think of Utah's Great Salt Lake, you might imagine a vast inland sea or a shimmering expanse of water, but today its surface has been shrinking at an alarming pace, falling to its lowest levels in recorded history, in fact. And as the lake bed becomes exposed, it isn't just an ecological issue, but it's also becoming a serious air quality and public health threat. So the Great Salt Lake is the largest saline lake in the Western Hemisphere, once covering nearly 3,300 square miles. In the past 150 years, human activity has profoundly affected it as river diversions for agriculture, industry, and a growing population have cut off much of the fresh water that used to feed it. Combine that with extended droughts and reduced snowpack in the Wasatch Mountains, and you have a lake that is disappearing. In 2022, water levels hit the lowest point ever measured, nearly 20 feet lower than historical averages. More than half of the lake's surface area had vanished, and that shrinking shoreline had exposed thousands of acres of dry lake bed. So what happens when that lake bed dries out? The sediments that are left behind are not ordinary dirt. For decades, rivers and streams have carried trace metals, agricultural runoff, and industrial byproducts into the Great Salt Lake, where they settled into the sediments below. When the protective cover of water disappears, those sediments become potentially vulnerable to the wind. So dust from that exposed lake bed, it contains arsenic, lead, mercury, and other toxic elements. Because the lake bed is comprised of very fine silt and clay, these particles are small enough to remain suspended in the air and travel long distances. On windy days, it can be carried into the Salt Lake Valley, home to nearly 1.3 million people. The dust problem also links to larger environmental issues. Just like Owens Lake in California, another dried up saline lake that has become the largest source of dust pollution in the United States, the Great Salt Lake could become a persistent generator of hazardous airborne particulates if its decline isn't reversed. Beyond human health, this dust also threatens agriculture, it degrades snowpack in the mountains by darkening its surface, and it disrupts regional ecosystems. So what's being done? Efforts are underway on several fronts. Utah lawmakers have passed measures to redirect more water to the lake, including incentives for farmers to reduce water use and providing funding for conservation projects. There are also proposals to physically stabilize some of those exposed areas, for example by planting salt-tolerant vegetation or using surface treatments to hold down dust. These approaches have been tried at Owens Lake with some success, but they are costly and labor-intensive. From a modeling perspective, this would be an interesting challenge. Modeling it as an area source would be the way to go, but calculating emissions, that would be tricky. Not all of the exposed lake bed is emitting dust. About 90% of the exposed section, in fact, is covered with a natural salt pan that prevents the lake bed from breaking and thus doesn't produce windblown dust. However, the remainder either doesn't have a crust or it has a crust that is eroding, caused in part by illegally driving cars and dirt bags on that dry riverbed. So to wrap this up, the story of the Great Salt Lake is not necessarily unique. Around the world, inland seas and terminal lakes are under similar pressure from water diversions, and certainly any lake that is shrinking isn't helped by a warming climate. The question now is whether we can learn from this story and act before it becomes irreversible.